Okay, friends, in this video, we are going to discuss about nuclear chemistry. What is nuclear chemistry? What are nuclear properties? What is atomic models? What are the nuclear reactions? And all the things we will discuss in this video. So let's start. What is nuclear chemistry? Nuclear chemistry includes nuclear property, nuclear radius, Coulombic and nuclear potential, spin and angular momentum, magnetic momentum of nucleus, then nuclear binding energy, then nuclear models. These are cell models, liquid drop model, Fermi gas model, collective model, then radioactive decay, nuclear reactions, evaporation, separation, spallation, fragmentation, fission, fusion, acceleration, accelerators, reaction cross section, use of radioisotopes as tracer. So these points we will include in this video. Let's start discussing one by one these topics. Okay. So what is nuclear chemistry? It is a subfield of chemistry dealing with radioactivity, nuclear processes, and transformation. So basically, nuclear chemistry deals with radioactivity. Radioactivity means an element emits radiation continuously until the stability of itself. Then nuclear processes means nuclear reactions, nuclear fusion reactions, transformation means the formation of new nuclei. We have parental nuclei, and then it is converted into another nuclei, that is transformation or transmutation. These are transmutation, actually, nuclear transmutation and nuclear properties. Nuclear chemistry is the study of physical and chemical properties of elements which are influenced by the changes in the structure of the atomic nucleus. So nuclear chemistry क्या है? These are the physical and chemical properties of element जो कि इस atomic nucleus के structure में changes लाते हैं. Changes means number of protons may be changed, number of neutrons may be changed, and if number of protons are changed, then ultimately nucleus is changed. For example, carbon has 6 protons, and suppose with the nuclear reaction we are preparing we are converting carbon molecule into 7 proton containing species, so it will turn into nitrogen. So that is the change in nucleus. Okay, so atomic structure kya? What is atomic structure? So we know that in atomic structures or in atom we include electron, proton, and neutron. Electron and protons, protons and neutrons, proton and neutron are found in nucleus. Okay, so basically we can say that atom is nucleus plus electrons. Okay, because nucleus centralized center में होता है, it is positively charged, and electrons are around this nucleus, right? So that's why its whole structure is the atomic structure. So atom is nucleus plus electron. So nucleus is the center part of atom, and it is completely positively charged. Why it is positively? Because it has or it contains neutron and proton. Neutrons are neutral, but protons are positively charged. So that's why nucleus is positively charged, and electron revolve around the nucleus in energy levels. Okay, so this is the simple atomic structure. Now we can represent an element like this. This is the basic symbol for atom, or it is atomic symbol, and it is used to represent atomic chemical formulas. X is the atom, name of atom, Z is the atomic number. It is related to number of protons. And A is the mass number. It is related to mass of number of protons plus number of neutrons present in nucleus. One more thing, proton and neutrons are known as nucleons. Okay, so many times it is also asked in examination that what are nucleons. So nucleons are proton and neutron. Okay, so this is the atomic structure. For example, if we consider carbon atom, so it has number of protons 6, it has mass number 12, it has number of neutrons are neutrons 6. And in the center part, there are 6 protons with the neutrons and electrons around this nucleus and the revolve. So this is the atomic structure, basic model for atomic structure. Okay. So initially that was whatever we have discussed right till now. That is that concept was given initially, and then the quark theory was come into the picture, and quark theory says that proton and neutrons are not fundamental particles. They are no longer fundamental particles. So this quark theory was developed in 1960. Why it was developed? Because it gives explanation about a proliferation of mysterious subatomic particle found in atom measures. Means whatever we are considering that nucleons are proton and neutron. So in early research, it was also found that in nucleus there are subatomic particles. Okay, so to explain subatomic particles, this theory was given. It was further developed up to present that अभी तक ये develop हो रही है या हुई है. Proton and neutrons are no longer fundamental particles. Okay, so initially it was considered that proton and neutrons are the fundamental particle of the atom or nucleus. But according to quark theory, the proton and neutrons are no longer fundamental particles. They are composed of quarks. Quarks are subatomic particles. Okay, free quarks are not stable, they quickly recombine. Quarks are bound together by gluons. Okay, so quark, what are the quark actually? Quark, these are subatomic particles. Okay, these are subatomic particles. And basically these are two types. First is up quark and another one is down quark. Down quark. Okay, up quark has plus 2/3 charge. It has fractional charge in fractional, and down quark has minus 1/3 charge. Okay, and these quarks are combined and form proton and neutron. And these are also combined and these are combined with gluons. So ये जो आपको दिख रहा है ऐसा, these are known as gluons, and function of gluons are to combine quarks. So when quarks combine, they form proton and neutron. So there are 3 types or flavors of quark: up quark, down quark, and strange. Strange को generally अपन इतना consider नहीं करते हैं, but up quark and down quarks are considered. Quark have fractional electric charge. अभी just मैंने आपको बताया कि up quark has plus 2/3 and down quark has minus 1/3. These are associated with each quark. These and anti-quark. The anti-quark has opposite properties: charge, baron numbers, and strangeness. Okay. So if we consider proton, so proton contain 2 up quark and 1 is down quark. So 2 up quark plus 2/3 charge positively, 2 by 3 charge positive, and down quark has minus 1 by 3 charge. So if we combine them, we will have plus 1 charge for proton. And in case of neutron, there are 2 down quark and 1 is up quark. Okay, so if we combine them, charge 2 by 3 plus 2 by 3 minus 1 by 3, then it would be plus 1. It is wrong. It will 2 down quark means 1 minus 1 by 3 minus 1 by 3 plus 2 by 3. So if we combine them, we will have 0 charge. So neutron has 0 charge and proton has plus 1 charge. So one more thing I want to tell you, the function of neutron. What is the function of neutron? Neutron, actually in the nucleus, there are proton and protons. Okay, so proton and proton are positively charged, so that's why they start to repel each other. Okay, so to minimize the repulsion between proton and proton, the neutrons are used. So proton and proton के बीच में न्यूट्रॉन आ जाता है, जिससे क्या होता है कि इनका रिपल्शन स्टॉप हो जाता है और मिनिमाइज हो जाता है. So by minimizing this repulsion between proton and proton, the nucleus gets stability. So there is an important role of neutron. But if you consider hydrogen atom, 1H1, so in 1H1, I'm writing here 1H1, it doesn't have neutron, no neutron. Why? Because it has only one proton, so there is no need of neutron to minimize the proton-proton repulsion, because there is absence of proton-proton repulsion. So this is the basic function of neutron. You must remember this. Okay, so now with this way we can calculate the charge. So in case of proton, there are 2 up quarks and 1 is down quark. In case of neutron, there are 2 down quark and 1 is up quark. Okay, in case of 5 plus subatomic particle, it has 1 and inverse of down quark. Similarly, down quark and 1 is up quark. So with this way we can calculate the charge. जो ये बार लगा हुआ है, what does it mean? It means up quark जो है वो क्या होगा, उसका उल्टा. Sign would be ulta. Just you have to remember these 2 things. Okay, now just change here a little bit. Charge, with this way we can calculate the charge, and with this way we can calculate the speed. Okay, so this is the basic nuclear structure according to quark theory. Okay, now come to the classification of atoms. Atom का अपन how can you classify them? Element not atom, element को अपन how can you classify? So there are 3 types of element: isotopes, isobars, and isotones. So in case of isotopes, isobar, and isotones are the these are actually these are element is classified on basis of these 3. These are category of classification of atom on the basis of number of protons, neutron, or mass. So isotope, atom of the same element. Same element के कुछ 2 atom है, for example अभी that's we will discuss. Same element के कोई 2 है, उनमें क्या होगा कि same atomic number, they will have same atomic number but they will have different mass number. For example, carbon 6C12 and 6C13 and 6C14. So what's happening here? There are number of proton. The number of proton are same, but mass number is different. 12, 13, and 14. So that's why these three are isotope of carbon. ये सारे क्या है कार्बन के isotopes हैं. Okay, so in case of isotope, number of neutron, how can we calculate? Atomic mass minus atomic number. So number of neutron in case of 6 is 12, 12 minus 6, 6. In case of 6 is 13, 13 minus 6, 7, 6, 14, 14 minus 6, 8. It means in case of isotope, the number of protons will be same, but number of neutron will not be same. This is the thing. So if number of neutrons will not be same, then number of mass number will automatically change. So definition, according to the definition of isotopes, isotopes are the element of atoms of same element having different number of protons, sorry, same number of protons and different number of neutrons or mass number. Another example is hydrogen. This is the 1H1, this is 1H2, this is 1H3. So protium 1H1, it has mass number 1. Deuterium, it has mass number 2, and tritium, it has mass number 3. So these are three isotopes of hydrogen. Now isobars, atom of the different element. These are atom of different element. Isotopes क्या है? Same element. जैसे we are considering carbon only here. We are considering hydrogen only here, right? But in case of isobar, these are of different element. So they have same mass number, but atomic number are different. If atomic number are different, means proton number are different. For example, cerium. So cerium has two isobars. Sorry, cerium and selenium. Okay. So both are having same number of mass. Mass number are same for cerium and selenium, but proton number are different. Okay. So number of protons are different, but mass number are same. So those are different, those are of different element and known as isobars. Second example, iron and nickel. If we consider 26 Fe, F58 and 27 nickel 58, it means atomic number are different, but mass number are same. So that's why these are isobars. Similarly, argon, potassium and calcium. All three have same number of mass. Mass number same, but proton number are different. So these are isobars. Third category is isotones. Atom having different number of protons but same number of neutrons. Isotones means number of neutron will be same. Okay, so those are isotones. So definition क्या हो सकती है? The atom which comes from different element but the amount of neutron is same. Example, phosphorus and sulfur. In both the cases, the atomic number are different, mass number are different. So number of neutron are same. If you calculate the number of neutron in 15p31 phosphorus, that is 16. And in case of 16 sulfur 32, neutron number are 16. So these two are the same. So that's why in case of isotone, number of neutron will be same. Fine. So these are basic classification of element: isotopes, isobar, and isotones. Now come to the nuclear properties. Nuclear properties क्या होती है? So in nuclear property, first we will discuss about nuclear mass. What is nuclear mass? So we know that an element can be represented like this: Z. Z is the number of proton. A is number of mass number. Okay, a mass number. Mass of atom, because for example, this is nucleus and these are electrons. Okay, orbitals where electrons are revolving around the nucleus. So this whole structure represents atom structure. Okay, so if we consider the mass of atom, so mass of atom, because atom includes nucleus as well as electrons are in the orbital. So mass of atom will be mass of nucleus plus mass of electron. and we know that mass of electron is negligible. Okay, negligible. Mass of electron is negligible, so we can neglect it. Now, mass of electron becomes mass of nucleus. So, mass of nucleus is mass of atom, and it is true for 99.75%. Okay, so mass of nucleus. Now we have to calculate the mass of nucleus, and we don't know that. Suppose this is nucleus, it has proton, it has neutron. So mass of nucleus will depend on proton and neutron, right? So ZMP plus A minus ZMN. ZMP, mass of proton and number of protons. This is the number of neutrons, right? Number of neutrons and mass of neutrons. So in दोनों को अगर if we combine or sum, then we will have mass of nucleus. Now we know that one atomic mass unit is equal to 1 by 12 of mass of 6 carbon 12. Now we consider 6 carbon 12 only here, not other element, because with respect to 6C12, the results are very accurate. So that's why we consider only 6 carbon 12. So 1 AMU is equal to 1 by 12 of mass of 1 C carbon, 1 carbon 12, right? So let's calculate the mass of nucleus. So 1 AMU is equal to 1 by 12 of mass of 1 6 carbon 12. Fine. Now an atom of carbon has mass 12 gram. We know that an atom of carbon's mass is 12 grams. So one atom of carbon mass will be 12 by n, and 1 mu, we know that 1 mu is 1 by 12th of carbon. So that's why 1 by 12 into 12 by n. So 12 cancel. Now 1 bond 6.023 into 10 to the power 23. So ये कहाँ से आता है? Because we are considering n. N means n is Avogadro number, and Avogadro number is 6.023 into 10 to the power 24. If we solve this, and at then we will have 1.66 into 10 to the power minus 24 gram. Now it is we convert it into kilogram, then it becomes 1.66 into 10 to the power minus 27 kilogram. Fine. So this is the mass of nucleus, 1.66 into 10 to the power minus 27 kilogram. This is the mass of nucleus. Okay. चैनल को लाइक कीजिए, वीडियो को, एंड चैनल को सब्सक्राइब करना ना भूलें. थैंक यू फॉर वॉचिंग दिस वीडियो.